In this online video, we are going to learn how to use Excel solver to help us optimize some decisions for different kinds of problems. So before we start, the first thing I want to do, I want to show you how to load the solver in your Excel. So for example, if you open Excel file, we need to go to File. It depends on what version of Office you are using. The exact procedure might be a little bit different. So you go to File, you go a little bit down, you will see Options. Then you click on the left hand, you click Add-ins. The solver basically is one add-in. You go to the bottom, you will see Go. If you click Go, you can see different add-ins available. So here you see we can see solver add-in. So check solver add-in. Then click OK. Then if you click the menu data, you will see solver in your toolbar. Now you can see solver. So this is how we load the solver. Solver is the free add-in. Now let's look at the first problem. The first problem is a common problem in rental car industry. So for rental car industries, companies need to redistribute cars at different time to balance demand and the supply. So for example, if you think about Florida, so Florida has the location has a very strong seasonality. So Florida attracts a lot of tourists, but because of weather, most people travel to Florida in the wintertime and in springtime. So people go there in Christmas, in New Year, and for spring break. But in summertime, because it's very hot and humid, the demand becomes much lower. So in this case, you can imagine in the wintertime, in the springtime, the rental car companies need a lot of cars. But in summertime, the demand will be much lower. So that's why they don't need so many cars. That's why companies need to redistribute cars. They need to ship cars from Florida to somewhere else. So if you look at this particular problem, for this particular rental car company, they have 6 different locations. So location 1 and 2. They also have location 3, 4, 5, 6. So you can think about 1 or 2. Locations 1 or 2 are location in Florida, and 3, 4, 5, 6 somewhere else. So at this particular time, location 1 or 2 had too many cars. So they had 16 for location 1. They had 16 surplus cars, and for location 2, I had 18 surplus cars. That means too many. They need to move this number of cars from these 2 locations to somewhere else. So they need to move 16 cars out of location 1 to somewhere else. They need to move 18 cars out of location 2 to somewhere else. So this is surplus cars. On the other hand, for location 3, 4, 5, 6, they need more cars. But currently, the number of cars available at these 4 locations is not enough. They need more cars. So how many cars are needed? So for location 3, it needs 6 more cars. For location 4, 5. Location 5, 15. Location 6, 8 cars. So 1 or 2 had too many cars. They need to move cars out from these 2 locations. And 3, 4, 5, 6, they need more cars. So they need to move cars to these 4 locations. So this is the decision problem we have to make. We have to decide how we're going to shift cars around to meet the demand. Similarly, if you look at the first table, the first table shows the cost structure to move cars around. So for example, if you want to move a car from 1 to 3, it will cost $22 per car. If you want to move cars from 1 to 4, it's going to cost $20 per car. Similarly, if you want to move cars from location 2 to location 6, it's going to cost you $28. So you can see, depending on the travel distance, the exact amount, the shipping cost to move these cars around are different for different location pairs. So this is given information. This is also given information, and this is given information. So now the question is, how do you want to move cars around? So what is our plan? What is our decision? So we have to make decisions how we're going to move the cars around. So of course, because we have Excel solver, we're not going to make decisions by ourselves. we want to rely on solver to make decisions for us. So before we do that, let's come up with one solution. Let's pick any arbitrary solution. So this solution may not be feasible, may not be optimal. It's just any solution you can come up with. So for example, so I'm going to start with the solutions. We're going to move one cost from location 1 to 3, 2 costs from 1 to 4, 3 costs from 1 to 5, and 4 costs from 1 to 6. I'm going to move 4 costs from 2 to 3, 3 costs from 2 to 4, and 2 costs from 2 to 5, and 1 cost from 2 to 6. So you may ask, so how do you come up with this solution? So this is a solution I have. As I said, it's an arbitrary solution. It's any solution you can imagine. It does not have to be the optimal solution. It does not even have to be the feasible solution. So just come up with some numbers. So this is, let's assume this is our solution. Because eventually, don't worry too much about it at this stage, because eventually Excel is going to change these 8 numbers. So these numbers eventually will be changed. So don't worry about it. So eventually Excel will determine the values for these 8 numbers and try to optimize it. So this is our current solution. So based on our current solution, what we want to know is how many cars are being shipped out from location 1. So 1 to 3, 1 cars, 1 to 4, 2 cars, 1 to 5, 3 cars, 1 to 6, 4 cars. So what we want to know is what is the total number of cars being shipped out from location 1. So we are going to do a formula. So based on this solution, what is the total number of cars being shipped out from location 1? So of course, we can do a sum. Basically, we do a sum of these 4 numbers. Basically, we're adding these 4 numbers. So how many? 10 cars. So we're shipping 10 cars out from location 1. Similarly, for location 2, how many cars are being shipped out? We can do a sum as well. So sum B8 to E8. So we're adding these 4 numbers. So total is 10 as well. So we're shipping 10 cars out of location 2 as well. So shipping 10 out from location 1, shipping 10 out from location 2. So remember, when we are filling the table, these numbers, everything highlighted in green. These numbers are the numbers determined by Excel. And these 2 numbers, we have to use formula, okay? We'll have to use formula. So we have to make sure if we change these numbers, so these numbers will change as well based on the formula. So we fill with formulas, not with actual numbers. So I don't want it to just simply type 10. I wanted to use formulas, okay? So these green numbers are decision variables. These are not. So these numbers are linked to these decision variables. So we have to create a formula to link these numbers with the decision variables. Similarly, if you look at location 3, so we need 6 cars to location 3. So based on our current solution, it's an arbitrary solution. Again, how many cars are being shipped to location 3? So of course, it's 1 plus 4 total. So we do a sum for each column. So sum B7, B8. So basically means B7 plus B8. So we're shipping 5 cars to location 3. As you can see, we need 6. We only ship 5, which is not even a feasible solution. But don't worry about it, because eventually, as I said, Excel is going to change the solution. So what about location 4? We need 5. So how many cars are being shipped to location 4? Again, we can do a sum of 2 plus 3. So it's at 5. So this is right. For location 4, it's perfect. So we need 5, we have 5. So 2 plus 3, basically C7 plus C8, or you can use sum function. What about location 5? You can do sum as well. D7 plus D8. So we are shipping 5 cars to location 5. How many we need? We need 15, which means this is not a good solution. It's not a feasible solution, but don't worry about it. What about location 6? So we're shipping 5 cars to location 6. We need 8 cars. So now we're done with the table. So basically, we give any arbitrary initial solution. So any number. You can, if you don't want type of number, just leave it blank. It basically means 0, 0, 0, 0. It's fine. Don't worry about it. As I said, Excel is going to change it. So give some initial solution, then fill the table by filling the empty cells with all the formulas. The last one we need to fill is what is total distribution cost. Given this initial solution, what is total cost? So what is total cost? We know to ship 1 car from 1 to 3 costs $22. We're shipping 1 car only. To ship a car from 1 to 4, it costs $20. We ship 2 cars. So what is total transportation cost? The total will be 22 times 1 plus 20 times 2 plus 25 times 3 plus 31 times 4 plus 28 times 4. Similarly, you can do all the way to the end, plus 28 times 1. So that's how we do it. That's how we calculate the total distribution cost. So in here, we can, again, we're going to use a formula. You can use a long formula. As I said, you can do 22 times 1, or in other words, B3 times B7 plus C3 times C7 and do it all the way to the end. You can do this. This is more sophisticated. So here, I'm going to use something easier. So the way it's structured like this. So we have 2 tables, okay, exactly same size. We take one element from each table and do the multiplication, and eventually add them up. If you see a structure like this, we can use a function called sum product. That means we do product first, we do multiplication first, then do a sum, add all the multiplication together. So it's called sum product. For sum product, it takes 2 parameters. So first of all, I choose the first table, that's a cost table, and I put a comma in between. Then I choose second table, that's a quantity table, how many cars are being shipped from each pair of locations. So it's called sum product. That will calculate the total cost, total distribution cost. Okay. So from now on, every time you see a similar structure, you can do the sum product. So you can save it. So now we're done with filling the table. So this is called initial solution, and we fill the table by formulas. So of course you can see this is not good solution. Okay, this is not even feasible solution. So now we have to use Excel solver to determine what is the optimal solution. So before we use solver, we have to understand that for each decision problem, there are 3 elements. The first element is you have to be really, really clear. What is your objective? So there are oftentimes when we deal with decision problems, there are multiple solutions available. Okay. So how do you pick the best solution in terms of what? So what is your objective? So in this class, oftentimes we are talking about 2 kinds of problems. Sometimes if you're talking about total cost, we want to minimize the total cost. So some other time you want to talk about the profit, and we want to maximize the profit. So oftentimes your objective is either minimize cost or maximize profit or revenue. So these are the 2 common problems we see in a decision problem. So in this example, what is your objective? So your objective is to minimize the total distribution cost. So we want to come up with a plan so that the total distribution cost can be minimized. So we change these numbers to make sure this number is the smallest possible. So this is called objective. So that's the first element. Second element we have to be really, really clear is what are the decision variables. We call decision variables. So that basically means what numbers can be changed, or in other words, to be determined. So what numbers are to be determined? What numbers can be changed? So in this example, everything highlighted in green are the numbers to be determined or to be changed by Excel. So these A numbers are called decision variables to be determined by Excel decision variables. So we have objective, we have decision variables. The last one we call constraints. So what are the constraints? Okay. So if you don't have a constraint, we can simply pick any numbers we want. But oftentimes we have constraints. For example, in this particular problem, if we don't have any constraints, let's say we don't have constraints. If we do not have any constraints, we can simply choose 0 for all the numbers here. We can put zeros here, for total distribution cost will be 0, right? But however, 0 is not good. We cannot put all type zeros for all these 8 different numbers, because if we put all zeros, then we cannot meet the constraints. What are constraints here? The constraint here is, first of all, we have surplus costs for 1 or 2. We have to move 16 cars out. We have to move 18 cars out from location 1 and 2. So this is the one constraint. So we have to move 16, 18 cars out from location 1 and 2. Same time, we have to move 6, 5, 15, and 8 cars to location 3, 4, 5, 6. So these are the constraints. So we have one constraint, we have two constraints. We cannot simply pick 0. Okay, so we have two constraints. So now let's go to Excel Solver and specify these 3 elements: objective, decision variables, and the constraints. So go to Solver. So once you click Solver, you can see the first thing you see is called Set Objective. So what is Set Objective? That means what is your objective? So I go here, I click this, I choose my objective. So my objective is my total distribution cost. I pick G9. So that's different options. You can either maximize or minimize it. Okay, max or minimize. In our problem, do you want to maximize total distribution cost, or you want to minimize total distribution cost? Obviously, we want to minimize it. So we pick minimum. Then afterwards, you will see by changing variable cells. So what are changing variable cells? So changing variable cells are basically what are your decision variables. So what is your decision variable? So in this case, all the green numbers. So I pick this, I choose all the green numbers, basically from B8 to B7 to E8. I choose all these green numbers. So these are the decision variables. So when you're choosing these numbers, basically you're telling Excel Solver that, so play with these numbers. Don't touch anything else. So only play with these numbers. Try different values for these numbers only. You don't touch other things. So these are the numbers Solver can play with, okay, not other numbers. So now we have to add a constraint, the last element, constraint, subject to the constraints. So how many constraints in our problem? As I said, there are 2. So we have to add first constraint. So how do you add a constraint? Click Add. So what is the first constraint? As I said, the first constraint, you have to make sure you will be moving 16 cars from location 1 and 18 cars from location 2. The constraint, basically, these are the number costs need to be removed out from location 1 or 2. So these are the actual number costs being moved out based on your solution. So these are the actual number costs being moved out from location 1 or 2. These are the required. So the constraint is we have to make sure these 2 numbers are exactly the same as these 2 numbers. Okay, currently, they are not exactly the same. That means this is not a feasible solution. So we have to make sure it's a feasible solution. So we have to make sure these 2 numbers are the same as these 2 numbers. So how do you set up the first constraint? Cell reference, the left-hand side, we choose these 2 numbers, F7, F8. The middle, I choose to make sure it's equal. So F7 and F8 has to be equal to what? To G7 and G8. So that's how we set up a constraint. So F7 and F8 has to be equal to G7, G8. So that is the first constraint. Click OK. So once you click OK, you can see under constraints, you can see that is the first constraint. F7 to F8 has to be equal to G7, G8. Now let's add a second constraint. So second constraint, so these 4 numbers, bottom, these 4 numbers are the number costs need to be moved to these 4 locations. and this column, this row, these 4 numbers are the actual number cost being moved to these 4 locations. So we needed this many, but we're shipping these many cars to these 4 locations. So obviously you can see currently only location 4 is enough, but not for location 3, 5, and 6. They need more cars. So in terms of constraint, we have to make sure the actual number of cars, which is row 9, actual number of cars being shipped to these 4 locations are the same as number of cars needed for these 4 locations. So basically, I want to make sure row 9, these 4 numbers in row 9 will be the same as the numbers in row 10. So how do you set up a constraint? Cell reference, I choose these 4 numbers. So basically, B9 to E9 will be equal to what? Constraint is that B10 to E10. So these 4 numbers are equal to these 4 numbers. This is how we set up the second constraint. So once you are done, click OK. So I have 2 kinds of constraints. So now we are almost ready to run the solver. So before we do it, I'm going to change the solving method. So if you see, select the solving method. So under solving method, there are 3 kinds of solving method. It's a nonlinear, simplex LP is for linear problem, then we have evolutionary. So for most of the problems we see in this class, so we're talking about linear problem. So this is a linear problem. So we barely use that evolutionary and nonlinear in our class. So this is that linear problem. So we use that simplex LP. So choose simplex LP. Make sure you choose simplex LP. Then click solve. So once you click solve, you can see solver will solve it. So now we have brand new solution. So this is a feasible solution that is determined by a solver. So now see, with the current solution, these 2 numbers are equal to these 2 numbers. So basically what I'm saying we're shipping exactly same amount of cost out from these 2 locations. You can also see these 4 numbers are exactly the same as these 4 numbers because we had the constraint. And total transportation cost, distribution cost, $801. So this is the best you can do. So if you try on your own, you can never do better than this solution. Okay? So $801 is the best you can do. That give you the lowest cost. So what is the final solution? This is the final solution. So we need to ship 6 cars from location 1 to 3, 5 cars from 1 to 4, 5 cars from 1 to 5, and 10 cars from 2 to 5, 8 cars from 2 to 6. So that is the final solution. So with this solution, the total distribution cost will be $801. So that's how we use solver to help us make decisions. So the procedure, basic procedure is you need to set up a table. You can set up a table. You need to understand in order to use solver, we need to understand 3 elements for a decision problem. We need to understand what is the objective. So here, distribution cost. What is your decision variable? So what numbers can be determined by Excel solver, and what is your constraint? Okay, here we have 2 kinds of constraints.